Look around you. Everything you see is made up of atoms. Everything. There are about 100 different types of atoms, and here's a display of all of the different types of atoms called elements that exist as we know today. These atoms combine to form all different types of substances. An example of the way that they combine is how hydrogen and oxygen come together to make up water. This represents a molecule of water, where you have the red sphere representing oxygen and the white spheres represent hydrogen. Two hydrogens and one oxygen come together and make water. How do they do this? The way the atoms combine to form molecules is by sharing their outermost electrons, or valence electrons. Each neutral oxygen atom has 6 valence electrons. How many valence electrons does each neutral hydrogen have? Atoms can share electrons, and sometimes this sharing brings them to a lower energy state. Atoms and molecules always do things that bring them to a lower energy state. Always. And in the case of hydrogen and oxygen, sharing electrons makes them lower in energy. The shared electrons form a chemical bond. Another name for this is a covalent bond. Scientists usually represent these shared electrons with lines, like this. Each line represents 2 shared electrons, or a covalent bond. Why don't you point to all the covalent bonds you see? By these covalent bonds. Remember, each line represents 2 shared electrons. This picture represents 4 electrons in 2 covalent bonds. If water is made up of 1 oxygen atom and 2 hydrogen atoms, how does it ever get to look like this? Molecules are tiny, too tiny for us to see, even with our highest powered microscope. Lots of water molecules need to stick together in order for us to see it as water. In fact, in each drop of water, there's about 1.67 times 10 to the 21st molecules of water. That's a lot. That number is really too large for us to even comprehend. In comparison, the age of the universe is about 4.35 times 10 to the 17 seconds. The number of seconds in the universe is about 4,000 times smaller than the number of water molecules in just 1 drop of water. That is a lot of molecules. So, how do all these teensy tiny molecules stick together? Remember, we said the connection between the oxygen and hydrogen atoms were made up of shared electrons, and that helps the whole molecule be lower in energy. But hydrogen and oxygen don't share the electrons equally. In order to get to an even lower energy state, the oxygen pulls the electrons closer to itself, and the hydrogens let go of the electrons a little bit. They are still sharing, but the oxygen gets a little more than its fair share. Do you know what an electron is? An electron is a negatively charged particle. Because the electrons, which are negatively charged, are closer to the oxygen, this creates a charge imbalance in the bonds of the molecule. The molecule will be a little bit more negatively charged on the oxygen side and a little bit positively charged on the hydrogen side. Here's another representation of a water molecule. Which side will be positively charged? And what side will have a slightly negative charge? Do you know what happens when positive particles and negative particles get near each other? That's right. Positive and positives and negative charges attract to each other. So if another water molecule is nearby, the slightly negative part of that molecule is attracted to the slightly positive part of the other molecule. No matter how many water molecules there are, the slightly positive part will be attracted to the slightly negative part. These attractions hold the molecules close to each other. The attractions aren't as strong as the electron sharing that holds the hydrogen atoms to the oxygen atoms, but the attractions between the water molecules are strong enough to clump them together in order to form water droplets. Of course, that just shows you what the electrons in water molecules are doing. But remember, everything is made up of molecules. So what about other types of molecules? Carbon is an element that has 4 valence electrons. It can bond with hydrogen too. Do you remember how many valence electrons the hydrogen has? How many electrons did hydrogen share with oxygen when we looked at the water molecule? Each hydrogen atom has 1 valence electron. Neutral hydrogen atoms always start out with 1 valence electron, no matter what other atoms it's combining with. So when we start with carbon and add in our hydrogen, each carbon atom can share with 4 different hydrogen atoms. This drawing represents a molecule called methane. Methane is a colorless gas. If you have a gas stove at home, it probably runs on methane. Let's compare our drawing of methane to our drawing of water. Unlike oxygen, which pulls the electrons closer to itself, the carbon atom shares the electrons equally with the hydrogen atoms. The electrons are evenly distributed throughout the molecule. The uneven distribution of electrons in the water molecule makes one side of the molecule slightly positive and the other side slightly negative. But the methane molecule has evenly distributed electrons. Will there be any charged areas of the methane molecule? No. And if there are no charged areas, that means there's not as much reason for those methane molecules to stick together. And this explains why methane is a gas at room temperature. Water molecules, with their partially charged areas, can stick together much better than methane. So the molecules clump together and create drops of liquid. But why are the hydrogen and carbon bonds made up of equally shared electrons, and why do oxygen and hydrogen covalent bonds share electrons unequally? The answer is electronegativity. Electronegativity is just one of the many different properties that we can use to describe elements. Electronegativity is how an element can pull shared electrons. This periodic table is labeled with the element's electronegativities. Red corresponds to a high electronegativity, and blue corresponds to a low electronegativity. Which atom is more electronegative, carbon or oxygen? Oxygen has a much higher electronegativity than carbon, so it's better at pulling the electrons that it shares with hydrogen.